All right, thank you. All right, so I'm Taylor, and I'm a droneaholic. Oh, wrong meeting. Okay, I get to play with drones all day. So since I've graduated school, I decided that drones were cool. I wanted to play with them, so I kind of set myself up to be able to play with drones all day. So I kind of brought a bunch of them along. I'll talk about them all, and we'll go from there. So I brought a good 5 pages of notes here. I could drone on for like an hour and a half with this. So I'll try to, there's a football game tonight, I heard. Somebody had to remind me. So I'll try to keep it short, and you guys just ask lots of questions, shout things out, or raise your hand or something. That's all cool. This should be interactive. I want it to be, short, fun. But so without further ado, I'll start talking about drones. All right, so what is a drone? Start with a definition. Any good scientist should start with definitions, define things. The technical definition of what is a drone is this. It's an unmanned aircraft capable of autonomous flight. So this key word there is autonomous. Most drones, what we want to, technical people officially call drones, should be able to fly by themselves, nobody controlling it. But I think more commonly, people see any quadcopter, anything like this, though this one can fly on its own with GPS guidance. Most of the time, you just have the remote control. Grab that. And I'll juggle these here. So you fly around with one of these remote controls. And so people call this a drone. So the terminology is kind of loose. People see what we technically call a multi-rotor helicopter. They call it a drone. But technically, it should be able to fly by itself to really be a drone. All right, so that's that. This is that up there. All right, so the next thing is that if it's any unmanned vehicle capable of autonomous flight, then we have other things that are drones that you wouldn't think of as being drones. So this guy, I brought this along. Is this a drone?
Maybe.
Exactly, maybe. It depends on whether or not it's got the control box in it to make it fly on its own. So this thing here is just an autopilot box. You can mount one. Holy cow. You can put it in there and make it fly on its own. I can make the microphone fly too. Put one of these on there, go around the room. So any of these, what is normally just a remote controlled airplane, but it could be a drone too. So.
Yeah, you can take that microphone off if you need to.
Cool.
I want to see you fly. Yeah, I want to fly.
So one of the things I wanted to talk about, let's see if this works any better, is why in the world are we seeing all these quadcopters now? So this has been the last couple of years. They've been very popular. What has changed to make this kind of the most popular Christmas present this year? And what? Really? I heard it was. I don't know. Nobody gave me any. I had to buy my own. So I guess a little bit of history. The very first designs that people made for helicopters were actually had multiple rotors. But that was before they actually tried to build any of them. And then they tried to build them, and they found out in a hurry that didn't work. And the problem is, when you've got multiple rotors on your helicopter, is it's really hard to control them independently. So because it was so hard to control it, they had to come up with a new way to do it. Then that's where we get the single rotor helicopter design. So that came around in the 1930s. So I guess what's kind of interesting about single rotor helicopters is how they do the control for this. It's actually a really intricate mechanical device, and that's what they could come up with and work with in the 1930s to make a helicopter fly. So how do people think that a helicopter, a normal single rotor helicopter, controls which way it goes? If you ask a lot of laymen about this, they'll say, okay, it's got a rotor, and if it wants to go this way, it tilts the rotor up and goes that way, right? Or down, wrong. And Dan over there is the former helicopter pilot, so that's not it at all. So the gist of it is that a normal single rotor helicopter has got this really intricate mechanical device that when you move the cyclic stick, thanks Dan, that if you want to go this way, it actually adjusts the pitch of this rotor blade as it spins around. So if it's over here, it might be pitched up. That means it'll exert force like this because it's pitched up. And then as it moves around, it's flat over here. It stays flat and pitches back up. And it's flat, pitches back up. So that's how a helicopter works. So then if you want it to move forward, you put the pitch up in the back, right? So it puts force that way, tilts it forward, flies forward. Anyway, so it's a really intricate mechanical device to make it move around in space. So that's actually expensive to make. And what we figured out lately is how to get away with doing this with all electronics, so we can go back to putting these multiple rotors, and then we just control them all individually, vary their speeds, and we can make the thing fly around. So in order to be able to do that, we had to kind of solve a lot of technological problems. And so most of those have come about, actually. I've got it in my pocket. The reason we can do all this now, it's in my pocket, is this, the smartphone. So the reason we can make a multi-rotor helicopter now is because of all the little gizmos that are inside a smartphone. So I made a big list of them here, but they have what are called MIMs, accelerometers, and gyros. So this is microelectronical mechanical devices. So because they started putting those in smartphones, it made them really, really cheap. That means the hobbyists could start buying those chips, and they could make them, put them on their own little devices like this, and it was affordable. So the engineers could start designing devices with them again. Same thing with cheap GPS receivers. GPS is so cheap now because it's in all the smartphones. And then in general, kind of, computers have gotten cheap. So the other big driver is cheap control computers. So in order to fly any of these things, even this tiny little quadcopter has a control computer in it that makes it actually stabilize itself in flight. A couple other things that are actually kind of interesting is that, let's see, this guy might be interesting to show it. So you can see this thing's got 6 of these blue motors on it, right? So those are brushless DC motors. So this is a thing that we've known how to build for a while, but they actually have a control problem as well. And so we needed advances in just making the electronics to control brushless motors cheap. It means that we can put them on hobbyist level devices, and we can make drones now. So that's why we can build a multi-rotor helicopter, and that's why in the last 5 years we've really started seeing them again. They're actually less expensive and easier to build, so long as you have cheap computers, cheap drive electronics. And finally, there's cheap high-power batteries. There's another thing that we needed. And so those have just come around, just kind of the sort of virtuous cycle of the economics behind it. The hobbyist buy it, drives it down, then it gets put in toys, drives the price down more, and just kind of keeps going. So now it's come around that we can buy these things. All right. So now I'll just, if anybody hasn't seen one of these, I'll just fly one around a little bit just to have some fun. Then we can talk about what people are using them for. Sorry, put that there.
Am I on? All right. So just while he's doing that, when we start asking questions, we have 2 microphones in the room, and since we're actually filming this for a video, if you could raise your hand and one of us will come find you with a microphone. There's one here, and then there's one in the back, that the debonair gentleman back there by the kitchen. Thank you.
All right, so I'll just give a word of warning. This thing's got spinning propellers on it. If it goes out of control, completely haywire, and flies across the room, which it's not going to do, but if it did, it may give you a small cut. So I'm just giving you a heads up. about it right now. If you feel a little uncomfortable, feel free to back up to the, stand up, back away. I'll keep it up here on the stage, just so there's no risk of anybody being hurt. So this is a small quad. This one's not actually capable of autonomous flight. This one's just all completely remote control, and it's got a camera on the front. It's made for racing around, and you can actually fly it through the video goggles. But here, I'll fly this for a sec. So you, all right, so that's a quad rotor helicopter. This is a drone. Thank you.
So how much does that cost?
An arm and a leg, and a couple fingers if you turn the props on while you're.
Taylor, make sure you talk into the mic.
Yeah. All right. So that is, though technically not a drone, that's just a quad rotor helicopter, but that's what they look like. So now that you've seen one, maybe they're not so scary, or maybe they're more scary, I don't know. So this is Science Café, and somehow you guys invited an engineer up here to talk. But so I'll try to talk about drones and science then to make up for it. So drones, I think, the whole reason, I mean, not the whole reason, I just think they're cool, but one of the big reasons behind why I think they're interesting is they're going to have a lot of applications in science, and especially the kind of science that I've done a lot of work in, and that's called remote sensing. So basically, scientists in all sorts of disciplines and areas, such as like geography, archaeology, agriculture, plant science, and any kind of environmental, anybody who does science outdoors generally relies on some kind of imagery sensing of the area that they're in. So what I think drones are going to do there is actually make the acquisition of any kind of sensed data, it's going to make it 100 times cheaper. So people who have normally used satellite imagery or aerial imagery from an airplane, it's now a couple of orders of magnitude cheaper. So if anything ever gets 100 times cheaper, people do a lot more of it. So that's what's going to happen with drones. But there's actually some interesting things that it's not just a difference in cost, it's actually a difference in quality. So with drones now, you can actually take these little helicopters, you can fly low to the ground, and you can fly slow, and you can actually get higher resolution images than you ever could from a manned aircraft, and certainly than you ever could from a satellite. So this is actually, I think, changing their usability to be more useful to solve new scientific problems. So actually, one of the ones that I've been involved with is actually kind of a plant science agriculture problem, is the counting of plants on a farmer's field. So you can actually go out now, you can take a drone, get really high resolution imagery, and you can count after every single plant that comes up. You can see it in a high resolution image, and you can now take an automated piece of software and count every single one, tie it to a GPS coordinate, and a farmer could know now every single plant that emerges in his field. So this is kind of revolutionary capabilities that people haven't had before, and I think it's opening up a lot of new opportunities. Some other things that are cool about this is that they can fly below the clouds. So anybody who's used satellite imagery has known that the pesky clouds get in the way all the time. So that's a big thing, and you have in general a lower cycle time in that you can assess the images you got and go back out and fly again the same day if they weren't very good. So this is enabling, basically just making the science easier for everyone. So there's tons of other fields. There aren't just science. So people in the surveying industry are using these. So you can do in hours now with an aerial survey what used to take days or weeks as a surveyor. Power line inspection is a big one. It's actually the most dangerous job I've heard in the US is a power line inspector, because they fly normal manned helicopters and they have to fly right up to these high voltage power lines and go inspect them very closely. So that's an incredibly dangerous thing to do. That we shouldn't have to do that anymore. We've got, remote control helicopter technology that can get a camera close enough to go inspect things. Another big one is construction. So here's kind of a fun story. I was having some work done on my house 2 months ago, and it was on the chimney. And the way my house is, that the top of the chimney is like 40 feet up in the air, and the construction company was replacing some boards around the chimney, and they said it was all done. So I flew my little drone up there, and I took a look at it, and it wasn't all done. And so I called him back up, and then I sent him the pictures directly from my smartphone that was connected to my drone, and sent them the pictures, and they said, oh, yeah, okay, it's not done. We'll come out and fix it. So, I mean, that there itself paid for the whole drone. Another big one, actually, is in kind of search and rescue operations. So there's this, not really a company, an organization down in Texas called Texas EquiSearch. Normally, they were set up actually to do horseback, equestrian-based searches for missing persons, normally missing children kind of thing. And so there's a group that's got involved. They started out as model aircraft enthusiasts, now drone enthusiasts. They're going out and they're flying the search patterns out there for free. And so now you can get, you get a dozen volunteers out there flying. You can get a pretty good coverage of an area. So it's kind of would be a great application, except for the current FAA regulations aren't letting them do that. So I'll talk about that more in a second. So I talked about agriculture a bit, things like counting crops, but there's also monitoring the health of the crops, monitoring the drainage of your field. If you're a rancher and you want to go out and count your cattle, you can go out and fly a survey, see all your cattle real quick. If you want to go out and, there's actually a ranch in New Zealand, their like 8-year-old kid bought a drone. They gave him a drone for Christmas, and so he was out having fun with it. And he figured out that he could program it to go to every single gate on their ranch, right? So it's all autonomous. He just goes out there, presses the button, it flies to every single gate on their ranch, takes a picture, and then they know whether all their gates are closed or not. So they don't lose any of their sheep, in New Zealand by leaving the door open. Another kind of cool one is there's a company that's developing drones for dropping life preservers or life-saving rings out at the beach. So the lifeguard, instead of having to spot somebody and then get up off the stand and run out there, it takes actually a while to go out and then swim out to them. They can fly something out to them directly and drop a life preserver on them. So I think that would be a kind of cool, useful, to the extent the lifeguards are used anymore. But I was a lifeguard in high school, but the funding cuts. So that is actually, all the motors. The guy who makes this talks about how he just went online and said, I want a motor like this, this, and this, and ordered it from Alibaba. So that's been one of the cheap Chinese manufacturing has been one of the things that's made this accessible to everyone.
For batteries, do you just put in like D batteries or AA batteries?
Yeah, so they actually have very specialized batteries. And I'll pull this one out here. All right, so this is a lithium polymer battery. So these are very specialized in that they are very high current batteries. They can deliver a lot of power very quickly. They're not as dense. They don't hold as much power as a lithium ion, like what is in your laptop or your cell phone, but they're made for delivering a lot of power quickly. And so that's why with all these electric motors on there, they actually suck a lot of juice. So you need one of these in order to be able to provide enough power quickly to it. So this is a very large one, 6,000 milliamp hour. So this is probably a $70 battery pack. They're very unstable. You have to handle them properly. They can catch on fire if you do the wrong things. So, yeah, sure.
So then the next question from that would be solar power possibilities. Are there any drones that are solar powered?
There are actually some solar-powered drones, but this is in the fixed-wing airplane kind of realm. So there was actually a company that Facebook either bought or invested heavily in called Titan Aerospace. They built this big, huge solar sailplane, which has got, like 100 and some foot wingspan big, but it's effectively just a big flying wing that's completely laminated with solar panels. And so it's just a very efficient high altitude flyer that's made to stay up indefinitely. You wouldn't see anything like a helicopter, a multi-rotor helicopter being solar powered. Solar power just doesn't provide enough energy to do that. But for a large wing, it actually is efficient enough that you could do that. Yeah, you might put like some communications equipment on it. It's probably a little high for a camera.
Are there certain desirable or undesirable conditions to fly them in?
I missed. Raise your hand. Who's asking? Okay. Okay. So, are there undesirable conditions? Flying them indoors around people is generally bad. In general, flying them over crowded areas. These are kind of they don't have airworthiness certifications, so it could fall out of the sky at any moment. There was a person flying one in New York City who flew it into the side of a skyscraper from several hundred feet up, and then it crashed down onto the sidewalk, right next to somebody. So this thing is not particularly heavy, but it's a brick falling out of the sky, so it could do some real damage, and you wouldn't want it to hurt anybody with one of these. In general, all kind of aircrafts have weather related restrictions. If the weather's, you wouldn't want to fly it in the middle of a storm kind of thing. Sure.
When I was in first grade, I got a helicopter on a cord, and the first thing I did was flew it into a fence and it broke. How rugged are these units?
So these are actually getting to be very rugged, and in particular, this little racing quad that I have is made to be pretty much bulletproof, but it's basically just a really sturdy carbon fiber frame, and if you put all the electronics inside the frame, nothing's going to break. But the props are the big weak point. And so with these, you crash it a bunch of times, you just replace the props. These props are like 25 cents, so you just order a couple dozen of those, keep them as spares. You have to run out in the field and find it and pick it up and replace the props. But that's the big consumable item. Some of the other ones, I've broken the landing gear several times. So it's just kind of if it's well designed or not to withstand that kind of abuse.
So when you talk about payloads, on average, how much can a drone hold?
So the kind of consumer drones that you can buy now, for the large multi-rotors, we're talking 5 to 10 pounds upper limit. Mostly they're carrying around large digital SLRs with a large lens for the big multi-rotors. And even then, you get about 10 minutes of flight time because it's so heavy. This one, you can maybe put an extra pound or 2 pounds on it, but not very much. So you can put one little extra sensor on it. This one's got a GoPro camera on it with a gimbal that is there. And so it's almost at its payload capacity as it is. So they don't have a huge envelope for extra weight. But you get into the big multi-rotors and they're made for, carrying around an extra payload. Sure.
What do you as a doctor and an engineer do to work with drones?
Okay. So my day job actually is making software for dealing with imagery from drones. So I'm working on right now, trying to bring to market my software for counting plants in a field and doing large-scale image analysis applications online. So that's my day job right now. And although because it's not technically legal for me to fly these in any commercial fashion, all the work that I do is as a hobbyist. flying around, learning about it. But then for my actual commercial activities, I just make and sell software.
So is there such a thing as an underwater drone?
Yeah. So there's the acronyms kind of jumble up here. Is there a water drone? So there's, I mean, people have come up with all kinds of crazy things, but autonomous submarines are a big thing. Certainly people are working on it, so you could call that a drone in a sense. It's an unmanned vehicle that's autonomous and diving around. So yeah, it's definitely a thing. And I've never heard of people using the control software from these to run a submarine drone, but it could probably work. There's a lot of similarities in the... Yeah, the terminology is kind of loose. The question is, does drone just refer to something that's in the air? In general, I would say yes, but the terminology is kind of so fluid, it will become, the language is how we use it. And so if we start seeing underwater submarines and call them drones, then they'll be drones.
If you are flying a drone and you lose it,
Yeah.
can you send another drone out to find it?
It depends on if you have enough money, I guess. So, in general, I guess it depends on how you want to find it. If you send it out with with a camera and you want to look at the imagery, I mean, this is like nobody's really trying to do that, but I could come up with a way to do it. You could put a little beacon on there that's, people do have, so it's not as much of a problem as it used to be in the last 5 years, but sometimes they malfunction, you get flyaways, and so you thought you had it under control, and then zoom is gone, and so then you have to go find it. So people will put cell phone modems on there, and so it can broadcast back as GPS coordinates. So that kind of thing, the technology is there to do it, although it's not extraordinarily common to do.
So that's a good segue to GPS. So if you're trying to map, a little bit more technical question,
Sure.
if you're trying to map fields and you're relying on GPS to coordinate to your imagery, so how accurate is GPS in terms of the location when you're talking about rows of plants and
Right.
things like that?
So GPS by itself is not actually incredibly accurate. Standard consumer level GPS has an error of, I want to say, plus or minus 3 meters. So I mean, if you're trying to be down to the exact row of crops within a field, that's not actually going to get you there. Although it's not randomly just jumping around plus or minus 3 meters, it's kind of the drifts slowly over time. But there's a kind of mix of technologies of what ends up getting used there. So you get GPS to give you the rough location, then your photogrammetry software, your image stitching software, takes those images, looks at them all, fits them all together, and so it kind of makes things fit together. And then the final link in that is usually you have some kind of surveyed in key point. So the images fit together, and then you find that key point in the image and you say, this is exactly that point. So there's there's a whole discipline behind getting accurate coordinates, and don't have a super deep background on that. It's possible, but it's challenging.
Are you saying that the GPSs that they're using are not wide area augmentation system GPSs?
So the wide area augmentation system is, I believe, gives the satellite, what they call the satellite ephemeris, that is kind of, you can take that, I think it'll broadcast that, and then it gets the kind of error offsets from the satellites and kind of can make your measurement more accurate. So these do not have that. The standard drones do not have the wide area augmentation system, but I believe it's starting to come into play. So that gets it down maybe from 3 meters to 1 meter. But then if you want to get to even more accurate than that, then they start getting to these RTK systems, which stands for real-time kinematics. And so this is generally, you have a surveyed-in base station somewhere that you get an offset based on the base station and your rover unit. You can really figure out where that rover was in real time based on having that base station also.
Basically a loss system, local area augmentation system.
Okay, yeah, that would be it.
I'm surprised though, because almost all the GPSs sold now are loss.
It may be the case. It may just be that the software is not taking advantage of it. But you know, I'm getting out of my depth there. I don't know exactly. I just kind of know. I knew what he was talking about, but I get some credit, right? Anyone? All right. Cool. Well, let's.
The awkward silence. I was checking my phone. If we don't have any more questions. Oh, we do have one more question. Hang on.
So does anyone put other types of cameras on the drones besides just video and regular photographs?
So this is. Wow.
Whoa, feedback.
That's my lovely and beautiful and talented fiance there, Dr. Alina Zaire. She does her work in hyperspectral image analysis. So a big hyperspectral images are cameras that take beyond the kind of visible red, green, and blue. They also get infrared and ultraviolet and kind of all these different wavelengths in between. So people are starting to mount them there. It's a question of getting the sensors down to what they call size, weight, and power constraints. So when they're starting to get them small enough that they can mount them on a large UAV, large drone, and people are starting to get the imagery from the other kinds of sensors. But I think the big thing is still that scientists and commercial operators are not operating for the most part in the U.S. And so all the university research that wants to be done just is not being done, or if it is being done, they're not talking about it. So that's kind of where we are right now, and it should be advancing more in the next couple of years. Sure.
What kind of software does the drones consist of?
Okay, so there's, for the most part, just a standard multi-rotor helicopter has an embedded computer on it, which is just a way of saying it's a small computer that doesn't have an interface. And so that just does the basic kind of control stuff. So that gets the feedback from the accelerometers, and it says, well, the pilot told me to go this way, but it looks like I'm going like this. So it does the corrections based on the feedback control to make it go the way that it's supposed to go. So that's kind of low-level flight control software. And then they might have kind of higher-level control loops based on my waypoints for GPS. So then it kind of, when they're flying autonomously, they have another layer of control on top of that. And that's generally all of the software that's on board with the drone. Usually everything else, it's easier to do it offline on your PC, your tablet, or whatever after the fact. So, yeah.
Questions over here.
He's, yeah. Well,
All right, okay, that's a lot better. So when you've got these programmable drones and you give them separate waypoints, and it starts flying there, does it know what obstacles are around it, or does it just go high enough so it avoids everything?
Yeah, so right now, if you're doing this autonomously outdoors, you should know what you're flying over and expect nothing to be in the way, because they don't have any real sensors and they will fly right into it. So it's a big area of research, and a lot of the commercial companies are trying their best to get around this, to develop what they call sense and avoid technology. And so this is the idea there, is that it's using the onboard cameras or maybe some other sensor to sense what's in proximity of it and not hit it. But that's not a thing that, for the most part, really exists yet. Maybe there's some university labs where they're working on it. And I just saw a demo from CES. If you guys follow this kind of thing, this was just like last week. So Intel or somebody was demoing their sense and avoid capability. but it's not there yet. It's going to be several years, I think. And that's going to be one of the big things, like for Amazon to be able to deliver a package, they got to be able to make sure that your dog's not right there, you know, that kind of thing. So it's a big step that's needed, but it's not there yet.
Are you gonna fly the itty bitty one?
Yeah, definitely. If you guys, you know, here, I'll try to set this up. So go ahead and ask a question, and I'll try to get this going, flying.
I have a question. Are there any drone-friendly countries?
That is an excellent question. There are countries that are drone ignorant, which, you know, you kind of just do whatever you want and you'll get away with it. And then you pay the guy $20 if he catches you. So other countries than the US, from my understanding, are better in that they do have a defined procedure. So Australia, the UK, even Canada have much more of a defined procedure in that if you wanted to be a commercial operator, you could actually go do it. There's a process that you can go through. And the US is really just starting to get their process online. For the most part, it's like I can't really apply through that process now in the US. So other countries, I believe, are better about it. But I don't know of anybody. So I'll kind of delve into the realm of opinion here. I think that if you're on your private property and you're below, say, like 500 feet, that's kind of your property and that you should be able to do what you want there. And if you wanted to hire a contractor to come in and fly on your property, he should be able to do that. But that's not the interpretation of the law. That's just kind of wishful thinking. So if the FAA or somebody decides to set up this kind of a free space kind of buffered region where you control your local airspace, I think that's the direction we kind of need to head to. But I don't know that that is the official law of the land anywhere. All right. So you can go ahead and ask questions. I'll just mess with this thing. So this one, if it did hit you, since I'm flying it while holding a microphone, it may pinch, but it's not going to cut you.
Where did you get that one?
So this one's actually, okay, this is the Blade Nano QX by Horizon Hobby out of Champaign, Illinois. They're a big hobby shop. You can order it online. So these are, when I bought it, it was around $100, I believe. And you have to have the remote control already. But you can buy these things. HobbyKing.com is a great source for all things cheap Chinese and flying. And then Horizon Hobby, I've had great experience with them. They're nearby in Illinois, so you can look at their website. They've got all kinds of fun toys. There aren't very many local hobby stores anymore. I haven't even actually looked in Columbia to see if there is one, but I haven't heard about it.
Hobby Lobby?
Yeah, Hobby Lobby is the worst named company ever. Sure. Here, there's like an invisible line here. If I cross it, it's going to feed back.
Sorry. Are there hobby drones that you can buy that you can then play around with programming them?
Oh yeah. Yeah, so okay, some good places to start there. There's several options. So things based on what they call the APM autopilot. So you can get the cheapest ones of those in the couple $100 range, again from hobbyking.com. Or you can go to 3D Robotics, and so they sell the APM autopilot and things based on that. They're a little bit more expensive. There's also the Parrot AR drone, which is something that the first versions of it came out probably 5 years ago. And so they actually have a Linux-based computer on them, and so you can there's whole kinds of distributions of software that you can do all kinds of fun stuff. You can take your Xbox controller and do it, hook up to your laptop, then a radio control from your laptop to this. But actually, no, it's Wi-Fi, so it just works. So yeah, there's all kinds of options, and I can go on about them for a while. But the AR drone is very hackable, and anything based on the open source autopilots, so the APM-based autopilots, you can start getting around and playing with it. You know, in the low hundreds of dollars is all it would take.
I hate to be Debbie Downer, but we do have to, they're going to kick us out of here if we don't vacate for the game at some point, I believe. So once again, I would like to ask you to thank Taylor Glenn for a wonderful presentation. I don't want to get too close to him because we're around demon mics here. So just a quick note before I always forget something at the beginning, and this time I forgot to tell you what the next Science Cafe will be, which the next Science Cafe will be up, it's always the second Monday of the month, which next month will be February 9th. And we're going to have anthropologist Mary Shank, who's going to start a conversation, I hope she's going to start a conversation about the myths and truths of love and marriage, which coincidentally